Hi, welcome to my Mathcast. The intended audience is grade 3. The learning objective is to interpret area models to form rectangular arrays created by Madelyn countrymen. The vocabulary we will be using is area model, and square unit. Area is the total number of square units needed to cover a two-dimensional surface. In this example, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 square units to make up the area of that rectangle. Our next word is area model. Area model of multiplication is a model by which two numbers being multiplied are represented by the dimensions of a rectangle, and their product is represented by the area of the rectangle. In this example, we have two numbers, 3 and 6, and they're multiplied together because they are the dimensions of a rectangle, so the base and the height, which we have 6 and 3, and their product being 18 because 6 times 3 is 18, is the area of the rectangle. So the area is 18 for this area model because 3 times 6 is 18. A square unit is a square with sides that measure 1 unit, used to measure area. And this is the unit that we use because all area units are squared. In our first example, we have 1 inch by 1 inch, which means it is a 1 square inch block. Then we have 1 centimeter by 1 centimeter, so it's 1 square centimeter block. And then 1 millimeter by 1 millimeter, so it's 1 square millimeter block. One helper we will need is that 1 inch is equal to 2.54 centimeters. You'll need this for example 3. For our first example, we see the area of Benjamin's bedroom floor is shown on the grid to the right. So this is Benjamin's bedroom floor. Each block or square represents 1 square foot. How many total square feet is Benjamin's floor? So first we have to label the side lengths. So let's count. This side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11 11 units. Then if we count this one, we get 1, 2, 3, 4, 5, 6, 7, 8, 9 on this side. So now we have our side lengths of Benjamin's floor. Next, we need to use a straight edge to draw a grid of equal size squares within the rectangle. So I'll use a brighter color so we can see. Let's draw out our horizontal lines. And we see that we have all 9 horizontal lines, and now we can draw our vertical lines. Your best bet is to use a straight edge because that will be much more accurate and easier to see. So now we have the straight edge to draw the grid of equal size squares within the rectangle of Benjamin's bedroom floor. So now we have to find the total number of squares. And if we remember, we can use the area model of multiplication to multiply the two bases together, being 11 and 9, to get how many squares, or the total number of squares, in Benjamin's bedroom floor. So area equals length times width, and then the length is 11 units, and the width is 9. And these can really go either way for this problem. So we have 11 times 9, which equals 99 square feet. Because there are 99 total squares, and we saw that we were measuring and that each square represents 1 square foot. So now we have that there are squared units, which that is incorrect. We have to put squared feet, and that is how you would write squared feet, or you can put square feet. So 99 square feet. Our next example is to use area, the definition of area, and find the area for C, which it's the same either way. And we see that these two rectangles are equal. So first, we can count the sides. So this one has 1, 2, 3, 4, and 1, 2, 3. And really, an easier way of doing this is to just count them all. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 square units. In our next example, or the other half of this, is to measure out. So we saw that there are 4 horizontally and 3 units vertically. So 4 units by 3 units we know is 4 times 3, which is 12 square units. Our final example is Fiona draws a 24 square centimeter rectangle. Gregory draws a 24 square inch rectangle. Whose rectangle is larger in area? How do you know? So first, let's draw out Fiona's rectangle. Here's Fiona's rectangle, and we can write that it is 24 square centimeters for the area. Next, we can find that Gregory has a 24 square inch rectangle that he draws. And we remember from our helper that 1 inch equals 2.54 centimeters. So we can find this because if we start with 24 inches, we need to find centimeters so we can equally compare Fiona's rectangle and Gregory's rectangle. So we can do 24 over 1, then we multiply it because the 1 inch and the inches in the 24 for Gregory's rectangle have to cancel. So we have to do 1 inch times 1 inch because since it's squared, that's 2 inch pieces. So we have to do 2.54 centimeters times 2.54 centimeters because we have the 2.5 centimeters equals 1 square inch, and we have to, or 1 inch, and we have to do that twice because we are measuring in square inches. So now, once we do the math, we see that we multiply 24 times 2.54 times 2.54 because the inches squared cancels with both of the inch units on the bottom. So then we have 24 times 2.54 times 2.54 all over 1 times 1 times 1. And when we use our calculator, we see that this is 154.8384 all over 1, which means that Gregory's 24 square inch rectangle is 154.838 square centimeters rectangle. And 154.838 is much larger than 24 square centimeters. So, as a comparison, this is not accurate, but Gregory's rectangle is much larger than Fiona's rectangle. And we see this because Gregory's rectangle is larger in area because when we convert 24 square inches to square centimeters to have equal units, so we can compare, we see Gregory's rectangle has an area of 154.838 square centimeters, where Fiona's is only 24 square centimeters, and 154.838 is greater than 24. Thank you for watching my Mathcast. I used the Engage New York website for my lesson and the MLC Math Vocab app by Madelyn Countryman.